people are dead so far. Schools closed across the country. 4,400 flights canceled. Many businesses at a standstill. All the result of a pool of cold air known as a polar vortex, bringing with it the coldest chill in decades.
Imagine a force so powerful, it can unleash a cascade of icy air, capable of transforming bustling cities into winter wonderlands overnight. This isn't a scene from a sci-fi movie. It's real, and it's happening right above us. Welcome to the world of the polar vortex. A colossal whirlpool of frigid air, lurking in the stratosphere over the poles. But what happens when this icy giant stirs from its slumber? In today's video, we're diving into the heart of one of nature's most formidable phenomena. We'll explore how changes miles above the Earth could turn our winters upside down, and why this year, the polar vortex might be gearing up for an unprecedented display of its frosty fury. Polar vortex overview. Picture this. At the top of our planet, encircling the Arctic, lies a massive, swirling mass of cold, dense air. This is the Northern Hemisphere's polar vortex, a giant cyclonic weather pattern that's as intriguing as it is influential. Located in the stratosphere, a layer above where most of our weather occurs, the polar vortex is not a recent phenomenon. It's been a part of Earth's climatic system since time immemorial, playing a pivotal role in shaping our winters. The polar vortex is like a refrigeration system on a colossal scale. It's essential in maintaining the temperature balance on Earth, particularly between the equatorial and polar regions. Throughout history, the strength and shape of the polar vortex have varied, influencing weather patterns across the globe. When strong, it keeps the polar air tightly locked over the Arctic. But when it weakens, that's when things get interesting. A weakened vortex allows frigid Arctic air to spill southward, bringing with it the potential for record-breaking cold spells and dramatic winter storms. Surrounding this icy giant are the polar jet streams, fast-flowing air currents that act as a barrier, keeping the cold air contained. However, when these jet streams meander or weaken, the icy grip of the polar vortex can reach us, turning mild winters into memories of white landscapes and frozen days. Polar jet streams rule. As we delve deeper into the workings of the polar vortex, one element emerges as crucial in this atmospheric dance: the polar jet stream. But what is the jet stream, and why does it hold such power over our weather? The jet stream, a ribbon-like corridor of fast-moving air high in the atmosphere, plays a pivotal role in the global weather system. It forms at the boundaries of air masses with contrasting temperatures, the frigid polar air and the warmer air of the mid-latitudes. Think of the polar jet stream as a guardian of the polar vortex. When it's strong, it acts like a colossal atmospheric wall, encircling and containing the icy air of the vortex within the Arctic Circle. The jet stream is not a static entity. It's dynamic, influenced by a variety of factors, including the Earth's rotation, geography, and even changes in the climate. Throughout history, the jet stream has experienced shifts in its strength and path. These changes are critical because they can dictate the behavior of the polar vortex. When the jet stream weakens or its path becomes wavy, it no longer can hold the polar vortex at bay. The result: frigid Arctic air escapes, cascading southward, leading to spells of severe winter weather far from the poles. A strong, stable jet stream maintains a balance, keeping the colder air confined to the polar regions. But when it falters, that balance is disrupted, bringing the chill of the Arctic to our doorstep. The jet stream is more than just a high-altitude wind. It's a key player in the global climate system, a force that shapes our seasons and weather patterns. Its dance with the polar vortex is a delicate one, a balance that, when tipped, can lead to dramatic changes in our weather. Potential weakening of the jet stream. In our journey through the realms of the polar vortex and the polar jet stream, we now encounter a critical and concerning phenomenon: the potential weakening of the jet stream. This isn't just a minor fluctuation, it's a shift that could redefine our winters. Imagine the jet stream as a mighty river of air, flowing rapidly in the upper atmosphere. Its strength and speed are pivotal, But what happens when this river starts to slow down and wander off course? A strong jet stream is like a tightrope, stretched taut, holding the polar vortex in place. But as it weakens, it becomes more like a slack rope, undulating and allowing cold air to spill southward. Recent studies and observations suggest a troubling trend. Our jet stream is showing signs of weakening. Scientists are investigating why, considering factors like global warming and its impact on temperature gradients. The weakening of the jet stream is a complex issue. It's tied to the warming of the Arctic, which reduces the temperature difference between the poles and the equator, a key driver of the jet stream's strength. As the Arctic warms at a faster rate than the rest of the planet, this critical temperature gradient diminishes. The result: a slower, meandering jet stream that can no longer effectively contain the polar vortex. What does this mean for our weather? Potentially, a lot more variability. We could see more frequent and intense cold outbreaks in mid-latitude regions, harsh winters, and even extreme weather events. Areas that are accustomed to mild winters might suddenly find themselves facing the icy wrath of Arctic air. The implications are vast, from agriculture to daily life, from ecosystems to economies. To truly understand this, let's dive into the mechanics. Mechanics of the polar vortex. We now turn our attention to its mechanics, the inner workings of this vast whirlpool of cold air that hovers over the poles. Understanding these mechanics is key to deciphering its impact on our planet's weather. The polar vortex isn't just a static mass of cold air. It's a dynamic, swirling system. Think of it as a colossal atmospheric tornado, but instead of tearing across the landscape, it hovers high above the poles. This vortex rotates counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. This rotation is due to the Coriolis effect, a result of the Earth's rotation, which lends the vortex its swirling motion. Located in the stratosphere, the polar vortex is above the weather systems we experience daily. However, it's far from isolated. Its strength and behavior have profound effects on the weather below. In the troposphere, the polar vortex undergoes seasonal transformations. In winter, as the polar region receives less sunlight and temperatures plummet, the vortex strengthens, becoming more defined and expansive. During summer, the polar vortex weakens and can even become fragmented. But in winter, it's a dominant force, capable of influencing weather patterns thousands of miles away. A strong polar vortex typically means a more stable and confined cold air mass over the poles. However, when it weakens, this cold air can spill out, leading to outbreaks of severe winter weather in lower latitudes. The reach of the polar vortex is vast. It doesn't just affect the polar regions. Its influence extends across the northern hemisphere, altering jet streams and thereby our weather patterns. When the polar vortex is disturbed, the effects can be dramatic. Cold air plunges southward, bringing with it freezing temperatures, snow, and ice. These are not just brief cold snaps. They can be prolonged, intense cold events. In recent years, we've witnessed several such events. Instances of extreme cold and heavy snowfall in areas unaccustomed to such conditions are stark reminders of the polar vortex's power. Impact of Rossby waves. As we delve deeper into the fascinating world of the polar vortex, it's essential to understand the significant role played by Rossby waves. These large-scale waves in the atmosphere are key drivers in shaping weather patterns across the globe. Rossby waves, named after the meteorologist Carl Gustav Rossby who first described them, are undulating movements in the upper atmosphere. They form due to the Earth's rotation and the variation in temperature between the equator and the poles. These waves meander through the jet stream, influencing its path. As a result, they play a crucial role in the movement and intensity of the polar vortex. When these waves are strong, they can significantly distort the jet stream. Rossby waves are fascinating because they can move in both westward and eastward directions. Their interaction with the jet stream can lead to significant weather events, including the breakdown of the polar vortex. These atmospheric waves can have a profound impact. For instance, a strong Rossby wave can push the jet stream southward, dragging cold, polar air with it, leading to severe winter weather in regions typically spared from extreme cold. Remember the Beast from the East or the North American polar vortex incidents. These were examples of Rossby waves influencing the jet stream, and altering weather patterns, resulting in extreme cold and snowfall. Conversely, Rossby waves can also contribute to heat waves. When a wave traps warm air and moves it towards higher latitudes, it can lead to unusually high temperatures and prolonged heat events. Forecasting the impact of Rossby waves is a complex task. Their influence on the jet stream and, consequently, on the polar vortex makes weather prediction a challenging endeavor, especially when it comes to extreme weather events. With advancements in meteorological science and computing, we're getting better at understanding and predicting the effects of Rossby waves. This knowledge is crucial for preparing for and mitigating the impacts of extreme weather. Historical perspective. The polar vortex isn't a new player on the climatic stage. It has been influencing weather patterns for as long as the Earth has had an atmosphere. Let's delve into the historical perspective of this powerful phenomenon. Throughout history, the polar vortex has played a pivotal role in some of the most memorable and extreme weather events. These events offer us valuable insights into the nature and impact of the vortex over time. Consider the Great Blizzard of 1899, one of the most severe weather events in U.S. history. This catastrophic storm brought unprecedented cold and snowfall across much of the country. Such extreme conditions were likely influenced by a strong and southward expanding polar vortex. In more recent times, we've witnessed several instances where the polar vortex has had a significant impact. The winters of 2013 and 2014, for instance, saw the polar vortex bring unusually cold temperatures to parts of North America and Europe. What's fascinating is the pattern we observe. The polar vortex isn't static. It changes in strength and position over time, influenced by various factors, including global climate patterns. Comparing past and present behavior of the polar vortex provides us with crucial clues. It helps us understand how natural climate cycles and human-induced climate change might be affecting this powerful system. Historical data is invaluable in climate science. It allows us to track changes in the polar vortex over time, offering a window into how it may behave in the future under the influence of ongoing climate change. By analyzing this data, scientists can better predict the polar vortex's behavior. This is crucial for preparing for potential future extreme weather events that can have far-reaching impacts on our environment and society. Influence of El Niño. A key climatic player of the polar vortex emerges from the tropical Pacific, El Niño. This phenomenon, characterized by unusually warm ocean waters, extends its influence far beyond the tropics, even affecting the behavior of the polar vortex. El Niño occurs irregularly, typically every few years. It's marked by the warming of surface waters in the eastern and central Pacific Ocean. But how does this warming in the tropics influence the frigid polar vortex thousands of miles away? During El Niño, the shift in ocean temperatures affects global weather patterns. It alters the atmospheric circulation, leading to changes in precipitation and temperature across the globe. El Niño can disrupt normal weather patterns significantly. It doesn't just affect the tropics. Its impacts are felt worldwide, including the potential to weaken the polar vortex. This chain reaction starts with the warm waters of El Niño influencing the jet streams. These changes in the jet streams can then lead to a weaker polar vortex, allowing cold Arctic air to spill southward. Historically, El Niño years have been associated with notable weather anomalies. These include milder winters in the northern United States and Canada, and increased precipitation in the southern United States and parts of South America. Interestingly, the opposite phase, La Niña, characterized by cooler ocean waters, has a different set of impacts. It often leads to stronger polar vortex conditions, resulting in colder winters in the northern latitudes. Monitoring El Niño is crucial for predicting the behavior of the polar vortex. Advanced climate models now integrate El Niño data to forecast potential shifts in the vortex, aiding in better preparation for extreme weather events. El Niño's influence on the polar vortex is a striking example of our interconnected global climate system. Current and future forecast. As we've journeyed through the intricate dynamics of the polar vortex, it's time to focus on the present and peer into the future. What does the current and future forecast hold in the context of this immense atmospheric phenomenon? The current state of the polar vortex is a subject of intense study. Meteorologists and climate scientists are closely monitoring its strength and position, using advanced satellite technology and sophisticated climate models. As of now, observations indicate that the polar vortex is exhibiting signs of variability. Some models suggest potential weakening and increased meandering, which could lead to more frequent cold air outbreaks in mid-latitude regions. Global warming plays a significant role in the behavior of the polar vortex. The warming Arctic is reducing the temperature gradient between the poles and the equator, which can lead to a more unstable vortex. Looking into the future, the forecast becomes increasingly complex. Climate change is expected to continue influencing the polar vortex, potentially leading to more extreme winter weather events in places that are not accustomed to such conditions. Predicting these patterns is challenging. However, advanced climate models are providing us with valuable insights. They suggest that we might see more frequent and intense winter storms, alongside periods of unusually mild winter weather. This unpredictability underscores the importance of being prepared. Governments, communities, and individuals must be ready to adapt to a range of winter conditions, from extreme cold snaps to unseasonably warm periods. The future behavior of the polar vortex is a reminder of our changing climate. As we witness these shifts, it's crucial that we continue to advance our understanding and develop strategies to mitigate the impacts of extreme weather. As scientists continue to unravel the mysteries of the polar vortex, we'll keep you updated on the latest findings and forecasts. Stay with us for more insights into the world of weather and climate. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.